So hello everyone, today we are going to discuss about the graph. Okay, so what is a graph and all about graph. Okay, so graph is a non-linear data structure made of two things. One is a node vertices. Okay. One is a nodes and a second one is the edges. Okay. A graph is a non-linear data structure. It is made of nodes, vertices, connection, edges. Means suppose you represented real world or real life relationship, etc. Suppose this is okay. So this is our graph, and these are the nodes. Okay, nodes 1, nodes 2, and here node 3. Okay, and these are the edges joined to the two nodes. Okay, a graph is written as a graph equal to vertices and edges. It is a graph is written as a vertices and edges, where V is a set of vertices and E is a set of edges. Okay, so now a real world example of a graph. First, Google Map and GPS. Cities are a node, nodes are a, roads are a edges. In a Google Map, you can see these are the cities, and one city, second city, third city, and all cities are connected with the roads. Okay, here you can see. So these are the edges and these are the vertices. Okay, cities are nodes and roads are edges. Okay, so again next example is a social media. Users are nodes, friendship follow is an angle. Okay, users are nodes and followers or friends are edges. Internet network, routers, computers are nodes, cables are edges. Flight routes, airports are nodes and flights are edges. Okay, these are the real world example of graphs. For first, Google Map GPS is a best example. Everyone can understand easily. So, why do we need graphs? Because of the we use graph in many real world situation. You can see Google Maps, social media, internet network, and flight routes. That's why we use graphs, where many objects are connected to each other. Okay. Next is a basic graphs elements, means types of graphs. There is a four types of a graph. First one is a directed graph. Second one is a undirected graph. Third one weighted, and the fourth one is a unweighted graph. In a directed graph, edges are directions, but they are not weighted. Weighted means they are a count, like a suppose here is a one edges, one node, second node, third node, okay, fourth node. These are connected to the each other like this. Okay, so okay. So directed graph means there is a direction. Okay, edges have direction, like a there is only like A for suppose A, B, and C. There are follow direction. Okay, means like a one-way road. Okay, so there is a direction in, like in this graph, a directed graph means there is a direction, specified direction. Okay, you just have a direction like a to b, means a follows b, b to c, b follows c, c to a, c follows a. These are the directed graph. Unidirected, sorry, undirected graph means edges don't have direction. These are don't have a direction. Suppose there is a no directions mentioned. There is both way. Okay, a, b, c. There is a no follow. No, there is a no, not like a follows b, b follows c, c follows. There is no rule. There a follows b, also b follows a. Okay, so there is a edges don't have any directions. A directed graph they have a direction. Now weighted graph, unweighted graph. Weighted graphs mean there is a distance and cost. Suppose a to b distance is a 5, b to distance is a 6, c to a distance is a 1. Means weighted graph. Each edges has weight. Weight means distance or cost. Okay. And unweighted graph मध्ये only connections matter. Only there is a only connection matter. They are not a weight. I mean there is a no cost, no distance. Okay. Only connection is a matter in an unweighted graph, and in weighted graph there is a matter distance, cost between the two nodes. Like next one is a cyclic and acyclic graph. Okay. A connected graph, every node can reach every other node. Cyclic graph means there is a they follow cycle, like this type of f b c, there is a cycle. And acyclic means there is a not a follow specific means. Okay, this one is the example of a acyclic graph. Cyclic graph and acyclic graph, they form a cycle. Connected graph, every node can reach every other node. Graph representation in C++. Okay, so there is adjacent matrix, 2D matrix of a size V cross V. Okay, V, everyone know V means vertices. Okay, so it adjacent vertices 10. Okay, pros, these are the simple, and cons, waste spaces for a large graph. For a large graph they are waste spaces, but pros, these are the simple. Adjacency list, most really used adjacency list as computer adjacent matrix, use vectors of vectors. There is a size of 100. Vector int adjacent 100. Okay. So pros, save space, perfect for big graph. Big graphs are as well as big graphs perfect for abstract graphs, and as well as save spaces. How to create a graph in C++? Here is an example to create a graph in example. There is a library. Okay, int n, int main. N means our node, and m means our edge. Okay, C input n and m. Okay, if you input n is equal to 5, means 5 nodes. 5 nodes means how many edges? You can select 4. Okay, 4 means 8. Sorry, 4 5 6 as well as. Okay, vector int adjacent of n plus 1. Here is a for loop from I is equal to 0, I is less than m, I plus plus. Okay, m is our edges. Int uv, uv means there is a nodes, like u nodes and v nodes. There is edges. Adjacent u pushback v, adjacent v pushback u. Okay, remove for directed graph. Here is a return 0. So this is our graph and adjacent list, adjacent matrix. In next lecture we will cover in depth or in deep. So that's it for today. Please like, share and subscribe our YouTube channel. Thank you.